Yeah. Good evening, everyone. Welcome to BioVanguard Cell presentation. For today's presentation, Yash Khannani is our presenter, and he will be discussing on the topic lifestyle and occupational risk assessment of bladder cancer using machine learning based prediction model. So before going into the presentation, let me introduce Yash. Yash is currently working as a junior research intern at Renix Life Sciences, exploring clinical applications of wearable devices and extracting information from medicine strip for potential use in health monitoring and medical diagnostics. He is pursuing BTech in computer science and IoT at Geetham University, and his academic background includes AI, IoT, and data science, which projects in computer vision and web development, as well as an internship as a Java developer at Woodpecker Analytics. His experience at Renix has helped me to strengthen his expertise in AI and data analytics, which enables him to contribute to innovative healthcare solutions. He aspires to leverage technology to drive impactful advancement in data driven decision making. Now, I welcome Yash to start with the presentation.
Thank you so much, Uma. Today, I will be presenting a recent study that applies machine learning to assess the risk of bladder cancer using lifestyle and occupational variables. So let's get started. So just a background gist of it. So bladder cancer is the 10th most common cancer worldwide. Its risk factors span both on genetic and environmental exposures. This study focuses on modifiable factors like smoking, diet, recurrent infections, and occupational exposure to develop a predictive model. The motivation: many bladder cancer risk factors are preventable, yet are poorly integrated in clinical risk models. Our motivation was to apply machine learning to detect at risk individuals early using everyday diet, health, and work related data. The study design. This was a case control study with 692 bladder cancer patients and 692 healthy controlled, matched by age and sex. The data was collected from an Iranian Cancer Registry, making it one of the largest balanced datasets for this kind of work. The features are the variables used for prediction. The features included demographic variables like age, BMI, and sex. We also collected medical history, lifestyle habits like smoking and opium use, dietary intake, and exposure to occupational carcinogens. Let us move on to the methodology, the machine learning pipeline. We pre-processed the data through normalization, imputed the missing values, and performed feature binning. Six machine learning models were trained using five-fold cross validation in Orange software. It is a no code visual analytics platform. This is the overall pipeline. Let's talk about the models that were being used. There were a total of six models, as I mentioned: random forest, decision tree, neural network, naive Bayes, logistic regression, and gradient boosting. Each model was tuned and evaluated using accuracy, AUC, precision, and F1 score. The performance matrix. The random forest performed the best. As you can see, it has an AUC score of 0.86 and a precision of 70%. Decision tree and naive Bayes also performed reasonably well. These models promised for risk stratification. The feature importance. This is particularly for random forest. This bar chart ranks the most predictive variables in the random forest model. The recurrent infection, bladder stones, and the neurogenic bladder top the list, followed by smoking, opium use, and high sodium foods like ham and sausage. This is an example of how the decision tree is. It is a simplified version of the decision tree from the random forest model. The root node, as you can see, is a recurrent UTI, showing how early infections may drive risk. The tree guides prediction based on health history pathways. Next, we head over to the discussion. Our findings support well established risks like smoking and UTIs, but also highlight overlooked dietary and medical history features. Occupational exposures showed weak predictive power, possibly due to low variance in the dataset. Next, we move on to the comparison with the previous studies. Our results align with the past studies on smoking and urinary infections, but we add machine learning based ranking of these factors. Dietary risk, contextualized in the Iranian population, is also a novel contribution. Next, we move on to the strengths and limitations. The strengths include a balanced data set, multiple ML models, and a culturally grounded risk analysis. The limitations are all data came from a single country, self reported lifestyle factors may introduce biasness, and external validation is still pending. So, to conclude, the machine learning, especially random forest, can predict bladder cancer risk from basic patient history and lifestyle variables. This framework supports early detection and risk awareness in primary care and public health. The implications and the future work. This model can help in community based screening and targeted prevention. Future work includes validating the model across populations and integrating genetic or urine based biomarkers. Thank you for your attention. I am happy to take any feedback that you may have. You can also find me at yash@renix.org or my LinkedIn link here.
Thank you, Yash, for the presentation. Now, audience, the floor is open for the queries.
Thank you so much.
Okay, I don't see questions. So thank you, Yash, for the presentation. And audience, I thank everyone for attending the session and hope to see you all in the next presentation. Thank you.